Hello, welcome back. In this video, we will work on statistical functions on NumPy arrays, as NumPy is the fundamental package for scientific calculations and hence goes hand in hand for NumPy statistical functions. So, let's understand about it in detail. So we have worked on some universal functions where we have seen on the unary functions and binary functions, right? So when I say unary, that is related to working on the same single array, square root, logarithmic, exponential, and so on. When we go for binary universal functions, where you have taken multiple arrays, finding out maximum values, cumulative sum, cumulative product, and mod f, we have seen all of them, right? The same way as NumPy is basically the fundamental package for scientific computing, then statistical functions plays a very vital role, right? Because these statistical functions are generally useful to perform statistical analysis, right? Because whenever we say statistics, it is all about collecting the data and analyzing the data, right? Because you see, data science came from statistics only. The name has been changed because whenever we say statistics, it all includes analyzing the data, collecting the data, giving some predictive modeling techniques. But when you see the mask of it, when you keep the mask and we remove the mask, it has statistics. So data science is all about including statistical techniques because it has taken the roots from statistics. Whatever we dig, that's the reason Python is for anyone. In the same way, when you work on statistical functions, every one of us studied about those things, basically working on mean, median, mode, standard deviation. So we will be working on mean, variance, so standard deviation and median. So these are all the statistical functions where NumPy plays a very vital role when you are trying to work on it. And even we have already seen how to just throw out the maximum values out of it. Now with the help of these statistical functions, as I already defined A, so let me try to use the same above declared array and find out mean. So my array A is, so this is my 3 by 3 array. If I want to get the mean, so you already know what do you mean by mean. So mean will generally throw you out so whenever we declare mean, it determines the mean value. What do you mean by the mean value? It is a sum of elements divided by its sum of the elements divided by its sum. So obviously, how many number of elements we are having? 9. So add each one of them, and when I give a dot mean, so when I give a dot mean, automatically returns the average of the array. I need not go for axis. So 9 elements, and you could just directly see the result as 4.0. So mean is different. So mean is basically the sum of the elements divided by its total number of elements, that is 9. I need not write the formula for mean because every one of you know, right? So when you go for variance, so when I throw for variance, that is a dot var. So that is, it returns the variance of an array. For variance is all about how does it is being varying from the average or mean. So when I go for the variance formula, it is bit different. So I'll try to write the variance formula here because variance is nothing but the summation of each value minus mean square. So that means, so whenever I write variance is equal to, summation is nothing but sigma. So I cannot write sigma symbol here, so write summation of, take each value x, that is 0 minus, what is mean square? So 4. So take mean square. So that is nothing but, let me write x mean or something like, I'll just write mean. So mean, and so nothing but mean square. So what I'll do is I'll just throw this thing in braces and the square of the mean, that is 0 minus 4 square plus 1 minus 4 square plus 2 minus 4 square. Same in that way, and divided by n minus 1. Not the sum of elements, but we just take n minus 1. If you calculate it manually, you get the same result. So a variance is 6.667. In the same way, if you go for standard deviation, what do you mean by standard deviation? Standard deviation is basically how the numbers are being spread out. That's where this normal distribution curve comes into picture. That's the bell-shaped curve. Returns the standard deviation of the array. So that is basically, it is square root of the variance. So you could see square root of 6.6, because square root of 9 is 3, square root of 4 is 2. It lies between 2 to 3. You could see the result. See, 2.581. So this is how you could get some of these very well-known statistical functions, variance, standard deviation, and you might have remember what do you mean by median. as median will throw the middle element of the array. It differs for both odd or even. So first let's try to throw with this array because I have defined A. I'll try to give like this only A dot, and in this if I try to give median, I'm not getting median, but again I try to throw median, it will throw me an error for sure. See, it is attribute error. Why? N-dimensional array object has no attribute median. You cannot take median function directly on the array, but you should throw it with the package, that is np dot, then you throw with this median, then automatically it will show you median and it computes the median along the specified axis. You could just throw your array A, np dot median of A. What is the middle value over here? 4.2, because our array is this 0, 1, 2, 3, 4, 5. This is for the two-dimensional because the shape is 3 by 3. But what happens if I go on defining a one-dimensional array? Suppose like this, d is equal to np dot a range of, I'll try to take till 10. This is one-dimensional. So I give d. So d is equal to 0 to 9. So let me take left side. So 0 to 3 is 4 elements and right side 6, 7, 8, 9. So we are having two middle values. If you remember from childhood, what do? You take the average. Yes. So now if you go for median of it, so np dot median. So np dot median of what is our array? We will try to throw d. Then automatically it will take you the average of it. That is 4 plus 5, which is 9. 9 by 2 is 4.5. That's how median will throw you the average when you are having equally spaced values on both the sides. That is with the median. So even in the mean, we can also make some more different things. Suppose our array is A. So this is our array, right? We have defined. So when I try to take average of it, when I try to pass the mean, I have just directly given mean and I did not mention anything within this. But even we can mention the axis, right? Even if we mention the axis within it, suppose if I go according to the axis, if I directly throw A dot mean, it is calculating the entire mean by taking sum of all the elements by total by 9. But I want to go by axis wise, that is if I want to go row wise, that is 0 plus 3 plus 6, that is 9 by 3, it will give me 3.2 like this. 0 plus 3 plus 6, just make sure you give parenthesis, and if you just add by 3, because this you are going row wise, right? It is giving you 3.0. The same way if I mention A dot mean of, if I go according to the axis 0, that is row wise, then automatically it will give me 3.2, that is 3 point, that is the first first, second, third row element, the first element in each row, second element in each row, third element, that is 1 plus 4, 7, 1 plus 4, 5, 5 plus 7 is 12, that is 12 by 3 is 3 point, right? In the same way, if we could add one more function within this, that is keep dimension, because if you clearly observe in this, when I just throw these braces, it is giving me axis none, data type I don't want to change, and if you see keep dimension is false. If this is set true, the axis which are reduced in the left, they result as dimension with size 1. That means if you could just see this like this, A equal to axis, A dot axis equal to 0. Let me try to give, the shape is 3 by 3 for this. So when I go for B equal to A dot mean of axis 0 and I want to keep dimensions as true. Okay. Now what I'll do is, so I just run this. If I just print B, I could see the result. Okay, whether it is one dimension or two dimension, I'll just go with shape. When I go for P dot shape, what is the shape of it? 1 row, 3 columns. But if you just make sure, if you remove this, because that becomes a one dimension array, and when you just check the dimension of it. So when you check the dimension, that is B dot, how do you check the dimension? Ndim. So when you go for B dot n dimension, that is 1. That is the main difference when you are using keep dimensions. That transforms into another dimension. So I'll just keep it as true. Then you can easily understand what happens when we are giving keep dimension argument in the function. So when I go for B dot n dimension for this, it is automatically giving me a 2 dimension. The same thing you can go for taking on C is equal to A dot mean of according to column wise. You can go with column wise, that is by giving axis is equal to 1 and you can include keep dimension, the same format. So keep dimension, I'm enabling it as true. Then automatically you could see when you give print of C, or let me just try to throw C, you are going column wise. So it is of 2 dimension. You could just generally see it. So when I give C dot shape, automatically it is 3 rows and 1 column. You could see 3 by 1. So C dot shape is 3 by 1. So that's how you could see when you give keep dimensions within the main function in the NumPy, it will automatically throw you the different result. So that is how, if you want to change the dimensions, then you could include it. So this is all about finding out mean, variance, standard deviation, median. Along with that, we have already seen. So when I want to get the minimum value, then automatically I will throw a dot minimum will give me the minimum value. What is the minimum value in the array? Let me try to print the array again. So it is minimum value is 0, and even you can just get the maximum value. How do you get the maximum value? When you give a dot maximum, automatically it is 8. So min and max, so this will generate the min and maximum values in the array, because these all comes under, we have already seen, just I'm trying to revise it. So in the same way, this will throw you minimum and maximum values in the array. In the same way, you can also find out the indices also. I mean, which index the value is being maximum and minimum. So for that, we can use a function which in it called as argument minimum and argument maximum. So for that, what we can do is, so what I'll do is I just give, when I give np dot, let me try to see np dot argument minimum. So when I give np dot, let me try to give it, we are giving argument minimum. Yes, argument minimum. What is the array? It's our array is A. So the index position is 0 automatically. So argmin and argmax. So it is giving minimum index position. So minimum and maximum index positions which we could result. So maximum indices. So what is the maximum indices? It will be automatically 8, because we are going according to the, we are going accordingly. So np dot argmax. So when I give np dot argmax, and you could see it clearly, axis is none. If you want to, by default the index is into flattened array, otherwise along specified arrays. You could just mention the axis also. You could just try on that. You could clearly understand when you mention axis 0, axis different, that's where it clearly shows you the difference. So this is how we have worked on statistical functions by finding out mean, variance, standard deviation. The clear part is, in mean we have used the function, we have used the argument which is keep dimensions. That plays a very vital role, because most of the people will never ever be aware of that, but I wanted you to just make sure how does each function play a very vital role, right? So each argument in the function play a very vital role. Sorry to correct, and make sure you play with those functions, and you already know how to get the sum of all the values. You can directly use a dot sum. It will throw you the total element sum, because this is different from the mean. So if that is 36 by 9, the mean will be 4.2. That is the sum of it. So these are all basic statistical methods which are performed over an array. Just make sure you keep practicing. Any queries, I am there to help you out. Just make sure if you are good at creating arrays, that will be a very best foundation when we start working on pandas and making visualization. Then you can mold your career in multiple ways. So in this video, we have worked on different statistical functions, as they are used to perform statistical data analysis and find basic statistical concepts like mean, variance, standard deviation, etc. In the following video, we will work on reshaping arrays. Thank you. I hope you have enjoyed watching it. If you have liked our content, please do hit like button and do subscribe to our YouTube channel for more useful content and exciting updates. If you want to learn such practical content at an affordable cost with Microsoft certification and instructor support, please register at academy.codegnan.com. You can also download app from Play Store as Codegnan. Never hesitate to raise queries in the comment section, and please do reply with your suggestions for more practical videos. We'll be happy to come up with it. Thank you.